Okay, this question is called Aces. It says 52 cards are randomly distributed to 4 players with each player getting 13 cards. What is the probability that each of them will have an ace? So I already did a little bit of drawing here because it would have taken a while to draw this out. It's been redundant. But you're just imagining 4 players like sat around a circle and somebody just having 52 cards laid out in front of them and then just breaking it up into 4 ways and just handing out each of those breaking ups or breakings into one of the players. So just imagine all the cards laid out and each player getting a fourth of all the cards. Now we're saying what's the chance that each player gets an ace? So probability of an event just means total outcome space is the denominator, and then the numerator is the favorable outcomes. And so what's the actual total number of outcomes we can have? It's we only care about the aces in this question, right? It's how we don't care about the other cards. What is the probability that each player will have an ace? So if we're saying the cards are laid out, all cards side by side, each of the aces can go into one spot, right? And there's 4 aces, and we don't care about like, oh, ace of spades is preferred over the ace of hearts, right? We don't care about suits in this case. All we care about is the aces and they're being valued equally, right? So that means we don't care about the permutations, we care about the combinations that of ways you can put the aces in the deck. Now, if we care about just a combination and we only care about the aces and where they're placed in those 52 cards, then we would say that the denominator would be 52 choose 4. All the spots, all the ways you can choose 4 aces from 52. All the ways you can like plug in an ace into all the 4 different slots. That's the denominator. Now we have to see how many favorable outcomes are there. Well, let's say we have an ace, and we're trying to put it for like somewhere such that the first person gets an ace. There are 13 places the first card can go, the first ace can go, that would make it so the first person gets an ace, right? Because if the cards are laid out again, like all side by side, and we're saying we want how many ways for the first person to get an ace. Well, it's just saying how many ways can we choose one card from 13, right? Because the ace can go into any one of these. Any one of these slots, right? It can go into any one of these. And there's 13 spots there. So there's 13 choose 1 in this case for the first player, right? Player 1. Player 2, again, we want them to get an ace. How many ways can they get it? Again, 13 choose 1. How many ways can you choose one ace from that person's 13? Or also, how many slots can the ace go into that ensure that player gets the ace? Again, for the third, as you can see, there's a pattern going on here. Again, for the third player, it's 13 choose 1. And fourth player, it's 13 choose 1. And so 13 choose 1 is just 13. So we have 13 to the power of 4 over 52 choose 4. That is the probability that if 4 aces are distributed, or 13 cards are distributed to 4 players, that each player ends up with their own ace. Yeah, that's the answer.